But I'm Brian Foster, and I'm a soil scientist, work for NRCS, just like he does. And I'm down in Fergus Falls. I've been there like not quite 3 weeks yet. So prior to that, I was in Montana for 22 years, mostly making soil maps out there. And then in the last couple of years, we kind of got into a lot of this stuff. Not so much with the demonstrations, but with actually like studying the soil properties under these different management systems. And when you do that, when you dig the holes and really kind of look at it, you start to see some really interesting stuff. Now, like I was telling part of the group here before, the big difference for me coming in is I came from an area where it rains like 10 to 14 inches a year. So we are always moisture deficient. And here we have some different challenges. It's most likely the opposite. But what we're going to talk about is how soil health management can affect soil properties and how that can benefit the soil and ultimately benefit your farming operation. Because there's certain principles that with soil health management that you can apply anywhere in the world. The trick is to figure out how they work in your area, with your soils, with your operation. And I'm not going to pretend to have that answer for you, because I know. But I've seen enough of this stuff to know that it works. It's not an all or nothing deal, like we talked about no-till versus strip-till. You know, it's trying to implement as much of this stuff as you can and make it work for you. And the other thing I will add is it takes time to see the benefits, kind of just like with no-till stuff. I've seen that. I mean, we're talking sometimes years, 4, 5, 6 years, for things to kick in and really see the benefit. I suspect in this climate, you're going to see a benefit quicker than what we would see out where we were more dry. Because it was so dry, the soil biology, which drives all of this stuff, was sometimes slow to respond. And here, I'm guessing, like we don't even have worms in the soil up there. I mean, you see worms here, right? Literally the other day, I got paid to go out and count worms. It was part of a soil health study, and we dug up, it was like a foot by foot, cubic foot of soil, and we counted the earthworms. Pretty interesting. And right there, we saw one of the fields had been worked hard, and there wasn't much. And then we had one that was pasture with cover crops, and there was a lot of worms in there, and really nice structure. So, anyways, with that, yeah.
So, yep, I'm Eric Anderson. I'm the area resource conservationist. So my job is like Luther, you may have met in Crookston or Red Lake Falls there. I'm kind of the ecological sciences, the plant science stuff, the support person for him, and I cover basically from Hallock down to Morris. And we've gone into helping with assisting with the soil health and kind of being a support with that. So, and then also we got Donna Christensen from the Soil and Water Conservation Office in Thief River, and also Larissa. You got to tell me your last. Fitzgerald. Okay. So yeah, with that, and we're gonna kind of the goal of today is just to look at how the soil reacts when you stress it with water, or when we put water on. Sometimes it comes a nice soaking rain, sometimes it comes all at once, and we're going to do a little bit of a heavier rain and just see how it moves through, how much runs off, how much moves through the soil profile, and just kind of get some ideas. When I was out gathering the samples from your fields, I liked what I saw. It wasn't black. You guys are already doing some things that are positive steps, like Rick was saying, or Brian was saying, it's not an all or nothing. It's kind of, the tenets of soil health are trying to keep a living root in the soil as long as possible. And for here, once our soil temperature gets down around 40 degrees, which will be hitting probably in a couple of weeks, 2-3 weeks, then the soil biota kind of shuts down for the winter. But there's still time. This year cover crops did really well because we had the moisture and we had the heat. So it made a good difference. And then the other thing is minimizing tillage. Which You know, this time of year, you know, when we drive around, things look pretty good. It's the thing to pay attention to is that, you know, kind of the critical time is right after the crop's been planted, because that's when, you know, all else being equal, we've done the most amount of tillage for the year, getting that seed bed ready, and getting things ready to grow. Unfortunately, that a lot of times leaves us the most vulnerable to erosion, you know. And around water erosion around here is not as big a deal as it is in other parts of the state, just because we're so flat. I mean, kind of the edges of the field or ravines, it can be an issue. But as you guys know, you know, when it dries out, gets warm and starts to blow, then we're vulnerable, you know, both for the crop movement, or I mean for the ground movement, or for, you know, the crop itself when it's just breaking loose can get damaged. You know, beans and wheat not as much. The sugar beets are real vulnerable because they start to rock and they also get sandblasted.
Yeah, so he talked about some of the basic principles there. The one was to, you know, minimize the disturbance, keep it covered. All of these are kind of interrelated. They all go hand in hand. So minimizing the disturbance as much as possible, trying to keep it covered to minimize the erosion. And that's also a shift in thinking where historically we've always been like just trying to control erosion. Now there's a whole idea that, well, we can do way better than that. We know how to control erosion, we do. So let's try to maybe build up our soils to what they used to be and regain what we lost through erosion. You know, it's regenerating the soil, trying to, and the whole reason we talk about all this stuff is to try to get the soil to function at its highest potential. Every soil has a potential, and we want to try to realize that highest potential for each soil. So that's why we're talking about this stuff. So Eric talked about living roots in the system, and then with that, trying to mimic nature where you have as much diversity growing as possible. So you'll see some examples of like cover crops that have multiple species, not just one thing. And then the fifth principle would be integrating livestock into the system. So what that does is if you have grazing animals out there, you're turbocharging that soil biology because cows are pooping, you know, you got all that biology that's recycling all that organic matter, incorporating that into the soil. That just really sends things off in a good direction.
Minutes or when we get to about an inch of rain onto the and we'll just be, as this goes, we'll make a few comments, you know, as the water's coming across, and we'll just kind of turn it on, watch, and see what happens.
The far left is the CRP next to the half section.
Okay.
The half section. Eric's garden by the church, and then David Road.
One thing you'll see as it's beginning here now, you'll see like my garden that's bare. You can look behind it, you can kind of see the dirt that's splashing up.
Mm-hmm.
You know, you see the same effect like if you ever set a tool down or a pan or something next to bare soil, how that water splashes up. You know, from what I've seen, they say the average velocity of a raindrop is about 20 miles per hour as it hits the soil. And what happens is all of your soils are made up of your different sized particles, your sand, silts, and clays. And through that action of that raindrop impact, it'll tend to separate things out a little bit. And then your clays and your silts are your smaller particles, and they'll kind of tend to, once that sample, if you take it out, set it in the sun on a warm day after this happens, that's when you tend to get that crust forming because it's separated out and your clays are sticking together. So, you know, and as we talked before, early on, like if this happens right when your crop is germinating, then you got a problem because you're stressing that plant trying to get through that crop. And you can also see, just so far we haven't put a lot of water on yet. But my garden soil here is already starting to run off. As Brian was alluding to, I've done rototilling on it. It's broken up that structure, taken out the pore space, so the water has a harder time moving through the down in and infiltrating, and it runs off pretty quick.
One thing they've noticed is when you mix in some of the residue, it doesn't seem to crush as bad in the spring. Is there any truth to that, or would you still just leave it on top?
Well, if you got residue that's sticking through the surface, if it's within that top inch or on top, it's helping you. Probably the worst situation is years ago we all used to mold the plow where we took all our residue and put it on the bottom and left our bare soil on top. And now even the move with chisel plowing, any residue that's sticking through is helping you. Obviously the more that you have, the better the odds that raindrop is going to strike that residue and take the energy out before it hits the ground and splashes out. So it helps that way. And then it also helps, if you've got that kind of that blanket layer of the clays and the silts, they stick to each other much easier than they do if you've got stuff disrupting them. And Brian, you can probably speak to some of that as well.
Yeah, the other thing the residue does is it minimizes the wild fluctuations in that surface soil temperature. So it just kind of stabilizes that. So it's maybe slower to warm up, but then if you get a stretch of dry weather, right, then you're really benefiting because it's just keeping that soil cooler too. So it minimizes the fluctuations in temperature, which really benefits that biology.
We noticed the difference, like our soybeans, we seed much thicker to try to get the ground to shade.
Yeah.
Because in the sand, it gets so hot. I mean, it'll get so hot you can't even touch the soil. Well, the top of the sand ridges, there's no residue. It eats it as fast as you can get it to grow on it.
You see it just decompose really quickly.
Yeah.
Yeah. No, this one's working the way it's supposed to.
Close, yes. Close.
The garden is really losing a lot of water.
Yeah. Yep, I think we're gonna have to come up with a conservation plan for it.
Yeah. I need help. Okay, I think we're pretty close to our inch here. Total amount of water leaving the field looks pretty good on each one of these. And then there's another part of this that we'll show you behind here that we kind of hid just for the moment. We can take this off and show you another part of the story. So then, what the back jar is the water that's moved through this soil sample, is infiltrated and gone down in. So, you can see with my garden, we had very little that actually moved through the soil. And then probably, I'm just looking here. The next one would be this is the one that's just to the west, the half section. Again, not a whole lot of water that moved through the soil profile, and even in the sodded area. So that means that most of the water here is being held, in the sample up here. Then as we move over this way, so on these two, this is the one that the millers that's been no-tilled. And here you can see that we moved a fair amount of water through this down into the subsoil. So, you know, the advantage of that is that it is there later on for the crop. It's not ponding at the surface. And then this one is probably a close second in doing about the same thing. So, and you know, the thing that the soil structure with worm movements, dead root channels and stuff is kind of what enables that water to move down through. That when we do more tillage, we disrupt those pathways so the water isn't.
So maybe I'll just go out on a limb here because I don't know these soils around here. But if you think of the soil as a sponge, okay, and it can hold the water, and when the sponge gets full, right, it's just going to run off, right, or run through. I think what we're seeing with the soil on the left, where we've got that good clean water and not much of it underneath the table, is that sponge effect is working to its fullest potential. And so if we had a lot of water, a lot of rain, right, that soil on that left is able to handle it, to deal with it. It's able to store that water so that the plant can use it when it needs it. These other ones, less so, to different degrees. So I think if we think of it as a sponge, and we want that sponge to be able, the soil, to be able to hold the water and make it available for the plant when it needs it, and not overwhelm, not let the water overwhelm the soil system like is happening on some of those other ones.
So, I mean, like here, if you have that's no-till, it's moving into your subsoil, but if your subsoil doesn't hold much water, it's gonna be gone.
Right, right. If you're, you know, like if you've got a gravel subsoil underneath this, then you got trouble.
So it can almost move through too fast on top if you have the wrong subsoil underneath. It can be just.
Yes, so you explained it better than I did, because that's what would probably happen with your soils here.